Good morning again, guys. I know some of you still had some questions about the finding the perimeter in the area and the coordinate plane, particularly the area. So I just wanted to show you something that you might find helpful. In order to find the perimeter of this figure, I know I can count this length as 3 and this length as 3. But the other two lengths, I am going to have to draw a right triangle and do Pythagorean theorem. So I need to find the length of RW. So here's the right triangle. It's a 2 by 5 right triangle. So to find the length of RW, I would do 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. C squared is 29, and the square root of 29 is 4.472 approximately. Okay, and then I would need to draw a right triangle to find the length of RB. So the right triangle would be this right triangle. Okay, it's 2 and 5. That would give me the length of RB. Luckily, I already have that because this ends up being a kite with two pairs of consecutive congruent sides. So if I wanted the perimeter, I would just add the 3, let me use a highlighter, 3 plus 3 plus 4.472 plus 4.72, and that would give me the perimeter. And it's approximately 14.944 units. So the perimeter is approximately 14.944 units. Now what I wanted to stress here is that once you've drawn those right triangles in order to find the perimeter, it actually gives you a way of finding the area, because we're only using the area formulas for triangle and rectangle slash square. So when I added these two triangles to the quadrilateral that I'm interested in, or the kite that I'm interested in, when I look at that total figure, I have a square. So I can figure out the area of this square. It's a 5 by 5 square. And then those two right triangles that I added in order to find the perimeter, if I take these two areas away from the area of the square, I end up with the area of that kite, the one that I'm really interested in. So it's going to be a two-step process. I'm going to find the area of the square, and it's a 5 by 5 square, so length times width or base times height will give me 25 square units for the area of the square, which would mean that if I counted the little squares inside of here, there would be 25 little squares. That's the area of the square. Now I need to find the area of these two triangles. Luckily they're congruent, so I only need to do it one time. I need to find the area of these two triangles to remove from that 25 in order to find the area of the quadrilateral or the kite. So the area of the triangle, remember that's 1/2 base times height. And luckily for a right triangle, the base and the height are built into the right triangle. The base is 5, the height is 2, so 1/2 of 5 times 2 would be 5 square units. So each one of these squares has an area of 5 square units. I need to take those areas away from the 25, the area of the square, and it will give me the area of that kite. So I'm going to subtract 10 from the 25. So the area of the kite would be 25, the area of the square, minus 10, the area of both triangles, or 15 square units. So what I'm trying to say here is that when you create the right triangles in order to find the perimeter, because I'm going to use Pythagorean theorem to find the length of it and C, I'm going to use Pythagorean theorem to find, whoops, that's not the correct right triangle, the length of CR, and I'm going to use a right triangle to find the length of TR. And notice that I'm going to do Pythagorean theorem 3 times there. I don't think any of those triangles are congruent, but what I end up with is a rectangle think it's a 3 by 6 rectangle with an area of 18. But in order to find the area of that weird looking quadrilateral, the one that I started out with, the one whose area I'm really interested in, I would then have to find the area of those 3 triangles that I drew to help me find perimeter. So the area of this triangle, the area of this right triangle, and the area of this right triangle. Subtract that from the area of the rectangle, and I have the area of quadrilateral and CRT. All right, have a great day, guys. Bye. See you Monday. No, tomorrow, Thursday.